on find nodal voltages VC and VD. There are four nodes A, B, C, D, and this is the ground, the reference node. So we need to find VC and VD. So here is a node, reference node. So we have to find VC and VD, nodal voltage C and D voltages. So in this problem, sometimes the data will be missing. You should check carefully. So this is a dependent source. It is a current source. Arrow mark is there means it is a current source. Diamond shape indicates it is a dependent source. Arrow mark indicates it is a current source. It depends on VC. It's a voltage controlled current source. You have to check VC in the entire circuit where VC is there. So VC is nothing but this is the voltage across this node VC. Okay. Then 6I1. This is a plus minus is there. This is a dependent source. Plus minus means it is a voltage source whose value depends on I1. You have to check I1. Where is I1? I1 is given here. So I1 is current through 2 ohm. So I1 can be written as current. Always in the nodal analysis, you have to write current in terms of nodal voltages. So it is VB, from VB is going VB minus VC divided by. So I1 is current through 2 ohm. I1 is current through 2 ohm, and which is equal to potential difference VB minus VC by 2. So that is the value of 6 I1. I1 is the dependent voltage source. It depends on I1 value. So next, this is the from figure. I1 is this much we already written, and one voltage we can directly tell with respect to ground. If you keep multimeter positive here and negative here, VB it will show as 8 volts because VB this side is at plus potential, this is negative. If I check multimeter voltage between these 2 points, it will show 8 volts. So VB is one nodal voltage is already known. So remaining 3 we have to write. And there is a voltage source present between A and D. So if there is a voltage source present between A and D, I cannot apply KCL for this. I cannot apply for KCL for A. I cannot apply KCL for node D. So solution is you have to form these two nodes and you have to form a super node. Form a super node. And we can directly write one equation. Plus is at A, plus is at A, minus is at B. So I can write VA minus VD is 6I1. VA minus VD is 6I1. Where I1 is VB minus VC by 2. That also we can write. Later we can substitute the value of I1 as VB minus VC by 2 and we'll get the expression in terms of VA, VB and VC. And after that we should apply KCL for super node. I cannot apply KCL for this because there is a voltage source. I cannot apply KCL for this because there is a voltage source. I can apply KCL for node C. So three currents are going away from this. I can apply for C. I cannot apply for B. I cannot apply for D. I cannot apply for A. But I can form a super node. Now I can apply KCL for this. These two currents from node A. These two currents from node D. So now let me see what they apply. Apply KCL at super node. 4 currents are there. These two and these two. So VA minus VB by 2. VA minus VB by 2. VA by 2. VA by 2 is because of this. VA. This is VA. Voltage at A is VA. Minus 0. Minus 0 is not written. VA by 2. Next VA minus VB by 2. So 2 currents. Next these two are from node A. From node B 2 currents. VD minus VC by 2. VD minus VC by 2. And minus 3 VC. This is going left side, but this current is coming right side. So minus 3 VC. Minus 3 VC. If you bring it to right side, it becomes plus VC. That is the thing, but current going to the node, and these three are current leaving from the node. These three, if you write these 3 VC at left side, minus 3 VC is equal to 0. If you bring it to right side, it becomes plus 3 VC. and we already know VB value. VB value is 8 volts. This is 8. VB is 8. We already know. And after that, if you simplify this, 0.5 A, 0.5 VA, 0.5 VB, 0.5 VD minus 0.5 VC, 3 VC, and substitute the value of VB. VB is 8, 8 5 is 40, 40 means 40, 4.0, 0 will go 4, for 4 volts will get. And simplifying left side and right side, and you have to substitute. You have to get in terms of VA and VB only. Sorry, ADC is there. ADC is there. You try to write three equations. ADC. I think instead of this, you can go for another method. Okay. You try to simplify this. You will get in terms of A, B, C. Okay. We will get in terms of A, B, C only. Don't write all these things. You do your own calculation. Okay. Your own calculation. 1 minute. So we can write, instead of going for this, what you can do is VB is equal to 8 volts. Directly we can write. So here from this equation, instead of going this complex method they have done. So instead of that, what you can do is, from this equation, from the figure, VA minus VD is equal to 6i, right? From the super node, VA minus VD is equal to 6i. This I1 value is VB minus VC. You substitute here VA minus, from this equation. From this equation, you can substitute this. VA minus VD is equal to 6I1. Okay. I1 value is VB minus VC by 2. So 2 3 is 6. So 3 VB minus 3 VC. And if you simplify, you'll get in terms of nodal voltages. VA plus 3 VC minus VD is equal to 24. This is equation number 1. So here they simply did unnecessary things in these steps. These steps are not required. So I'm going to simplify here only. Next, you have to write KCL for supernode. Two currents this side. I already told, two current this side and two current this side. So if I get VA by 2, VA minus VB by 2, VD minus VC by 2, minus 3 VC is equal to 0, bring it to right side, 3 VC, and 0.5 VA, 0.5 VA minus 0.5 VB, 0.5 VD minus 0.5 VC is equal minus VC. And if you simplify this, you will get 0.5 VA, 0.5 VA is VA, this is correct, and 0.5 D is also correct. And this okay. This if you bring it to left side, it becomes minus 3 VC. 0.5 VC is minus 3.5 VC. This is VA and 0.5 D. And you are going to get VB. VB is how much? VB is 8 volts. 8 4 is 8 5 is a 40. It is a 0.5. No, it is 4. That minus 4. If you bring it to right side, it becomes plus 4. So I will repeat once again. From the only for supernode, VA minus VD is equal to 6i. I1 value substitute as VB minus VC by 2. You will get one equation. Second equation, apply KCL for supernode, 4 currents, and try to get VA, VC, VD form. Okay, this is the second equation. And third equation, you can apply KCL for node 3, node C. These are node C, 3 equations. VC minus, I'll tell you, VC minus VB by 2, VC minus VD by 2, minus 4 is equal to 0, or 4 is equal to VC minus VB by 2, VC minus VD by 2. That is the equation number KCL at node 3. And if you simplify this, you will get third equation. This is equation number 3. Now write equation 1, 2, 3 in matrix form. So equation number 1 from this they got 1, 3 minus t. Coefficients are VA, VC, VD. VB is already known. So VA, VC, VD are the unknown variables. VA, VC, VD are the unknown variables. 1, 3 minus 1 is equal to 24. Second equation from this is VA minus 3.5C plus 5.5 VD is equal to 4. So 1 minus 3.5, 0.5 is 4. Third equation from node C, coefficient of A is 0. 0, 1, minus 0.5 is equal to. So these three equations, if you solve using calculator, okay, you will get, you have to enter 1. Okay, 1, 3 minus 1, 24. 1 minus 3.5, 0.5, 4, 0, 1 minus 0.5 is equal to 8. We are going to get answer as VA value. VA they have not asked. VA value is 9.14. Next to VC, three unknown variables are VA, VC, VD. VA, VC, VD. Next VC is minus 1.14. We are getting same answer. And VD is minus 18.3 or 18.28. So this answer is can easily get, is an important question. Next, another important, very, very important compared to that. This is very, very important question. This is a very important question. This will be asked for 14 marks. 14 marks or at least minimum 10 marks or sometimes 12 marks. It's a very, very important one. Find nodal voltages Vx and Vy using nodal analysis. So this is a given problem. In this is minus, this is plus, this is reference voltage. One voltage you can directly tell from the figure. V1, if you measure with respect to ground, it is minus. Here if I keep multimeter positive, minus is there, minus 12 volts will get. So V1 with respect to ground is minus 12 volts. Next, since we are doing using nodal analysis, you have to do using nodal analysis. Check any voltage is directly connected between this. So there is a dependent voltage source, minus plus. So it depends on Vy. It is a There is a voltage source between V3 and V4. So this is forms a super node. You can combine these two nodes. You can combine these two nodes and you can form a super node. You can combine this full node and this forms super node. And we can write one direct equation. V plus is towards V3. V3 minus V4 is 0.2y. And again, in the nodal equation, Vy and all should be replaced with nodal voltages V1, V2, V3, V4. Where Vy is here. Vy is given here. Vy is given here. So V1 is plus side, V4 is there, minus side V1 is there. So where Vy is V4 minus V1, because drop across 2.5 right side we have V4, this is V1. Difference between these two nodes is nothing but Vy is V4 minus V1. And one more, this is current source, dependent current source. Its value depends on Vx, where Vx is present between these two nodes, V2 and V1. Plus is towards this. So Vx is V2 minus V1. Vx is V2 minus V1. V1 is this. Next one direct equation is V1 is minus 12 volts. Now V3 and V4 forms a super node. I already circled with red color here. And we can directly tell that V3 minus plus is towards V3. V3 minus V4 is 0.2 Vy. V3 minus V2 is V4 is 0.2 Vy. And substitute Vy in terms of nodal voltages. So Vy is actually V4 minus V1. Substitute V4 minus V1. V3 minus V4 is equal to 0.2 into V4, 0.2 into V1. And finally, you are going to get in terms of nodal terms V1 or V2 or V3 or V4, no other Vx and Vy. So we are getting expression V3 minus 1.24 is equal to 2.4. And we already know V1. We already know V1. Unknown variables are V2 is unknown, V3 is unknown, V4 is unknown. So second, apply KCL at supernode. If I apply KCL at supernode, this is a supernode. One going away current is this side. The second one is this. And here I cannot write. And this current is this. This current is this. So V3, I will tell you four currents are V3 minus V2 by 2. And it is already a current. So minus, and it is opposite to, this current is opposite to this. So minus 0.5 Vx. And this current is V4 minus 0. It is V4 by 1. V4 minus V1 by 2.5. So those are the four currents. Four currents are this. Actually, this 0.5 Vx also it is written minus. If you bring it to right side, actually here it will come minus 0.5 Vx. And minus because it is opposite to the away current. If you bring it to right side, it becomes 0.5 Vx. And again, there should in this equation there should not be any Vx and Va. All should be in terms of nodal voltage V1, V2, V3 or V4. What is Vx? Vx is V2 minus V1. Vx is this Vx is plus is towards this V2 minus V2 minus V1, this Vx. So substitute 0.5 Vx, no? Substitute Vx as V2 minus V1. Substitute V2 as V2 minus V1. This is V2 minus V1. And V1 value is 12. V1 value is 12. Vx is V2 minus V1. V1 is already known, is minus 12. So we can write Vx as V2 plus 12 volts. We can substitute that Vx as volts V2 minus of is equal to this. And now simplify V1, V4 is there, here V4 by 1 plus V4 by 1.25. Then minus here separate V1 term. The V1 value is already known. This is V1 is minus 12. Minus 12 by 2.5. Okay, minus 12 by 2.5 will get 4.8, and V3 by 2 minus V2 by 2 is equal to this much, and separate V2, V3, V4 will get this equation number 2. Now apply KCL at node 2. I cannot apply KCL at 3. I cannot apply KCL at 1 because there is a voltage source. I cannot apply KCL at 1 because there is a voltage source. I cannot apply KCL at V3 alone, V4 alone, but I can combine these two and form V supernode, and on last we can apply KCL at node. Here I can apply. Three currents are this side, set three currents are away. V2 minus V1 by 0.5, and this is minus 14. If you bring it to right side, it becomes plus 14, and V2 minus V3 by 2. So that is a KCL at node number 2. You can write minus 4 here and bring it to right side means plus 14. And if I simplify this, you will get third equation. And after that, you can write these three equations in the matrix form, and you can solve. The unknown variables are V1 is already known, so V2 you have to calculate. V3, V4, V1 is already known as 12 volts minus 12 volts. So remaining three equations are, third equation is 2.5 minus zero point 0.5. V4 is not there. 0 is equal to minus 10. Then equation number 2 is minus 1.5, 1.4 is equal to 1.2. Equation number 1 is, there is no V3, V4 is there, V2 is not there. V2 is not there. So while writing, you should be very careful. 1, 1.1, 1.1, 1.2 minus 1.2 is equal to 2.4. Equal to 2.4. Now take calculator. Now let me enter the values. So I'll change the old values. Otherwise, I'll do separately. Equation number 5. Three unknown variables. A1 value is 0 is equal to 1 is equal to minus 1.2 is equal to 2.4 is equal to second line minus 1.5, 1.4, 1.4 is equal to 1.2. It's 2.5 is equal to minus zero point 0.5 to 0 is equal to minus 10. I'll check once again. Equation 1, actually this is V2 term is not there, 0 should be there. No? Let me check the answer first. If it is wrong, I will correct it. Oh, I think my mistake. V3 value, first equation, 0 is equal to minus 1 point, V3 is 1 is equal to 0.4 is equal to, minute I will do correct once again. Equation number 5, equation, this is 2, this is the equation terms are 0 is equal to 1 is equal to minus 1.2 is equal to 2.4 minus 1 is equal to 0.5 is equal to 1.4 is equal to 1.2 is equal to 2.5 is equal to 0.5 is equal to 0 is equal to minus 10. You get minus 4. A value is minus 4, that is V2. Minus 4. V3 is 0, 0, and V4 is 2, minus 2 also. You're getting the same answer. For that, they has got to find what? They has got to find what is Vx and Vy. What is Vx and Vy? Vx is V2 minus V1. Vy is V4 minus V1. V2 minus V1 and V4 minus V1. V2 minus V1 is, V2 is how much? V2 is minus 4. V2 is minus 4 and V1 is minus 12. It is minus 4 plus 12. It is 8 volts. This is V4 minus V1. V4 is minus 2. V1 is minus 12. Is minus plus 12. It is equal to plus 10 volts. So this is a very important problem. They'll ask for 10 marks. I think you can also, for I think this is the same problem. You can see here. This is V1 is minus 12 volts. KCL at node 2 is this. V3 and V4 form a super node. Like KCL, we'll get another equation. KCL at super node. This third equation. Solving these three, you are going to get same answer. This is textbook. Thank you.